Hi calculus student, this video is for chapter 3.2 but part 2. In part 1 we did a very important calculation or examples of how to find f prime of x given f of x by using the definition. Let's review the definition. So if I want to find the derivative function, it's called f prime of x. So that this function, whenever I plug in something, will give me slope of a tangent line. And we say x would approaches 0, and then it's a ratio of change of y over change of x, the secant lines notation. So f of x plus h minus f of x, or you can, if you remember, this is called the difference quotient. This is f of x over h. So when h is getting smaller and smaller, that means this second point is getting closer to h. You get the slope of the tangent line is equal to slope of a tangent line. So this is algebraic method to find actually a function. But if a function is giving us as a graph, can I actually sketch f prime of x? There's no limit to do. So we would just try to figure out at that point what is the slope. So again, this is just a sketch, right? So how are we going to do it? Say, for example, we have this. This is f of x. I want to sketch the graph of, this is f of x. I want to sketch the graph of f prime of x with the graph here given. cannot do limits. So the strategy is, first of all, the slope of tangent line is a line that touch the graph at one point. So let's look at those that are at the turning point. Because during the turning point, the slope is 0. Do you see that? Because it was going this direction, and then it was the slope, the tangent line is going this direction at here, and this is going down direction, and then all of a sudden it turned up. So at the maximum or minimum point, the slope of the tangent line must be 0. So the slope of the tangent line is 0, so we'll mark 0 here. So we mark another 0 here. And then let's look at in between them. In between them, where do we have this is all negative, right? So if you draw a tangent line, you can draw it this way, this way. This is a tangent line slope. This is a tangent line slope. All these slopes are negative. Do you see that all negative? So your tangent line should be like here. But at this point, this is when it is the most negative, most steep. So we'll say this may be the lowest one, approximately, I don't know, 2 or 3, so like that. So it's just a sketch. And then it's still negatives. All these are negative number, right? Start from here, from this, the tangent lines increase positive. You see how? So you would have positive number. What about here? Starting from this point is 0, the tangent line is 0, but these are all positive. And actually, it is not very positive here because it's like turning to 0, but it's going to become more and more positive. So this graph is our f prime of x. At any point, it tells us what the tangent line slope is. What about this one? This is kind of a square root function. So this is f of x. I want to find the slope of the tangent line. Okay, so the slope of the tangent line is like that, right? In the beginning, you can see that it is going the slope is very steep. It's very positive. So we can say at here point will be very, very negative. Here, these are also very, very positive, right? But at a certain point, you will see that it's almost 1, right? So I don't know when it is 1, but maybe around here it is 1. 1 is here. So you can see that it's And then it's still positive, but it's less and less positive, but it's never going to be a negative slope. You see how this graph, all the slopes are positive. So we'll have it equal to 1 and then gradually, getting closer to 0, but never drop below 0. You still be growing. It's positive slope, right? Positive slope. These are still positive, but very, very big positive. So this is the sketch of a square root function's derivative. And then the next things we want to talk about is the relationship between derivative and continuity. So obviously, if a function is not even continuous, then of course it's not differentiable because you can't really draw any limits. You can't really draw any tangent line, right? If there's a break or if there's a jump, how can you draw a tangent line? So, but there are cases where a function is continuous, but it's not differentiable. That means you cannot find f prime of x. So these are the 3 graphs below. It's kind of small. I can blow it up a little bit so you can see it a little better, and we can discover why this graph doesn't have a tangent line. So first is this one. So on all these points, the tangent line is just the same as that point, right? The slope is -1. And at all these points, the slope is 1, right? Because it's a absolute value function. But at 0, at x equals 0, on the left side, the slope is still going -1 really, really strong. It's always just -1. F prime of 0.0001 is -1, but f prime on just a little bit over, this is a negative and this is positive, would be positive. So can you draw the tangent line? The two slope is not the same. So at this point, there's no derivative function. It is not differentiable. It is continuous, but it's not differentiable. The second case is this one. If I draw a tangent line, what is the slope of the tangent line? The slope of this tangent line is like infinity, right? So we say if my f prime at 0 go to infinity, that means it does not exist, right? We cannot find a number to it, so that's not differentiable. The third one is a graph where your f itself like fluctuate and oscillating, so the derivative does not exist, cannot draw a tangent line. So like at this point you can draw a tangent line, at this point you can draw a tangent line, but it turns very sharp, and then at every single point very close to 0 is also not differentiable because you cannot find a limit of the limit of f of x plus h minus f of x. The last things we want to talk about is some interpretation of f prime of x. You see when we draw f prime of x from graph, it is the slope, right? And then when the f prime is going to this positive direction, so if you have a graph like that, this is the tangent line slope, this is the positive slope. And you can see the f is increasing, so correspond to this case. When f prime is negative, that means the slope is negative. That means your tangent line goes this direction. That means at that point, f will be decreasing. So by analyzing f prime of x, we actually know at which interval f is increasing or decreasing. So for example, P of t is the population of a city. If you plug in t, it would give you the population of the city at that time. So if you say P of 3, so that is the exact population number at year year 3 from now, 3 years from now. But if you do P prime of 3, so instead of tangent line now, this is a tangent line slope. Slope is also rate of change, right? Slope is rate of change. It would tell us per year at y equal 3, the change of population per year is how much? How much is it changing, right? If it is a positive number, that means population is increasing. So positive, p-prime of 3 is positive. That means it's increasing. The population is going to be increasing at year 4, or will be more at year 4. From 3 to 4 will be more. But if p-prime of 3, no matter what number is, if it's negative, that means the population is going to be decreasing at that point. Okay, so you can look at the sign of p-prime of 3 to see if the population will be decreasing or decreasing. So that is the interpretation of f prime of x. It's a rate of change, tells us whether f is increasing or decreasing. And that is the end of 3.2.